Okay, so let's talk about the inverse of function. If we have here the original function given by this form, f of x, then its inverse will be written in this form, or the function of x or the function of the inverse. Now, in taking the inverse of a specific function, we have to consider two things. The first, the domain of the inverse function is just the range of the original function, and the range of the function, the inverse function, is just, alright, let's edit this one. The inverse function is just the domain of the original function. So in the original function, we have x as our domain and y as our range. When it comes to the inverse function, we will be interchanging the x and y variables. So from x to y, this will become the set of y and x. Like for example, let's try to have an example. Given the function y is equal to 2x minus 1, if we will be making a table of values for this particular function, alright, let's say the values of our x or the domain are negative 2, negative 1, 0, 1, and 2. On the other side will be the y values or the range. Now don't forget that this is for the original function. So we'll be substituting the values of our x to get y. If x is negative 2, y is negative 5. If x is negative 1, y is negative 3. If x is 0, y is negative 1. And if x is 1, y is still 1. If x is 2, y is equal to 3. This is for the original function. When it comes to the inverse, the table of values will look like this. Just like what we did in here, we will be interchanging the values of x and y. We will be simply interchanging the variables x and y. So we have here x, y. 1, 2, 3, 4, and 5. The domain of the inverse function is just the range of the original function. So this is our domain in the inverse, and it is said that our domain for the inverse is just the range of the original function. So in here will be negative 5, negative 3, negative 1, positive 1, and 3. Second statement, the range of the inverse function is just the domain of the original function. So this is the range, and this is the domain of the original function. We'll be shifting all their values. So we have here negative 2, negative 1, 0, 1, and 2. But take note, not all functions has an inverse. The same with relations, not all relations are functions. Not all functions has an inverse, right? A function can only have an inverse if it is a one-to-one function. Right? Let me write it down. A function f of x has an inverse if and only if it is a one-to-one function. Okay, we have here a function f of x has an inverse if and only if it is a one-to-one function. So this means that not all functions has an inverse, only when it is a one-to-one function. So what is a one-to-one function? We have to recall the properties of a one-to-one function. It should have no even exponents. So when we say even exponents, those are numbers like 2, 4, 6, 8, 10, and so on. So there should be no exponents like that. And second condition that we must remember, it should have no absolute value form. These are the things that we should consider. Once these two are satisfied, then we are free to solve for the inverse of the function. Now, there are easy steps or three basic steps that we can use in solving or in finding the inverse of a function, right? The first step is you will be writing the function into the form y equals f of x. After rewriting the equation, you will be interchanging, right? Interchanging the x and y variables. And at the last step, we have for the third step, we will be solving the value of our y in terms of x. So let's have an example. Find the inverse of the function f of x equals 3x plus 1. So first step, we write the function into y equals f of x. So from f of x, we'll replace y in here, and our function, that is 3x plus 2. So we have y equals 3x plus 1 rather. Second, we interchange the variables x and y. Y becomes x, and x becomes y. Just copy the constants. Now we have x is equal to 3y plus 1. Take note that our third step is to solve for y. So we'll be needing to use the subtraction property of equality. We subtract 1 to both sides to eradicate 1 in here. So we have x minus 1 equals 3y plus 1 minus 1. This is 0, so we are left with 3y equals x minus 1. Still, we have 3 in here, so we can use the division property of equality to eradicate 3 from both sides. Now this gives us y is equal to x minus 1 over 3. Or rewriting this one into its inverse form, we have the inverse of the function x is just equal to x minus 1 all over 3. Now this will be your final answer. Also, you might be wondering why I haven't checked the function. This is already one-to-one because first, the exponent is 1 and 1 is odd. Second, there is no absolute value form. Now let's have a few more examples. Find the inverse. Right. Find the inverse of the following. Okay. Let's say this one. F of x is equal to 2x plus 1 all over 3x minus 4. So let us check. This is a rational function. Let us check if the exponents are not even. So this is 1 and this is 1. Therefore, it's safe. The exponents are not even and there is no absolute value form. Therefore, it is a one-to-one function. Now we are now free to execute the first step, which is to rewrite the form into y equals f of x. So f of x will be replaced with y and our function given by 2x plus 1 all over 3x minus 4. This time, the second step, we will be interchanging the variables x and y. So y, this becomes x, and all the x variables will be y. This gives us 2y plus 1 all over 3y minus 4. Now we can cross multiply this one. Remember that all the whole numbers can be written in the form x over 1. Any number that are whole, consider their denominators as 1. So we can cross multiply this. We have x times 3y minus 4 equals, we have 1 times 2y plus 1. Now we'll be distributing all these values. X times 3y, that is 3xy. X times negative 4, that's negative 4x, equals 1 times all the terms inside this quantity gives us the same values, 2y plus 1. This time, we have 3xy minus 4x equals 2y plus 1. So we will be regrouping these terms. On the left side will be the terms that has a y variable. We have 3xy and 2y. So we have 3xy minus 2y. This is positive 2y. Once moved to the other side, the sign will be changed. Positive, negative. The same with negative 4x. So on the right side, we'll be grouping those terms that has no y variable. This gives us 4x plus 1. Now take a look at these terms. They do have a common factor, which is y. So we have to factor that out. Take out y, and we're left with 3x. Copy the operation subtraction. Take out y, so we're left with 2. Y times 3x, that's 3xy. Y times negative 2, that is negative 2y. So we just simply factored it out. Let's copy 4x plus 1. Now let's continue. We have y times 3x minus 2 equals 4x plus 1. Take note that our goal in here is to solve for y. So we need to eradicate 3x minus 2. That is by dividing both sides by 3x minus 2 as well. So this gives us y is equal to 4x plus 1 all over 3x minus 2. Or we can rewrite this one that the inverse of x, or the inverse of the function x, is just equal to 4x plus 1 all over 3x minus 2. This will be our final answer. Now let's consider a few more examples. If I have here f of x is equal to, let's say, x squared plus 4x plus 2. So before jumping on the 3 steps in finding the inverse, we have to check first if this is a one-to-one function. Oops, take note, look at that. The exponent, or there exists an even exponent which is positive 2. Thus, this particular function has no inverse because it is not 1 to 1. Right, next, if we have here f of x is equal to the absolute value of x cubed. The same with this case, this function does not have an inverse because this is not a one-to-one function. So you have to remember all these conditions that must be satisfied before jumping and taking long solutions for your problem. Now let's consider this example. Let us have a recap on the compositions that we have discussed before. We do have the first composition and the second composition, the f of g of x and the g of f of x. So for the first one, f of g of x, this means that g of x will be substituted to f of x. And for the second one, g of f of x will be substituted to g of x. Now we will be using these compositions to prove or to show that the two functions are inverses of each other. So like for example, if our f of x is equal to negative 1/2 x and our g of x is equal to negative 2x. We want to show if negative 1/2 x is the inverse of negative 2x and negative 2x is the inverse of negative 1/2 x respectively. That is by using these composition of functions. We'll have two. So we have the f of g of x, right? Our f of x, that is negative 1/2 x. Take note, g of x will be substituted to the function of x. So x here will be replaced by negative 2x. We have negative 1/2, x will be negative 2x. So let's have negative 2x in here. Now negative 1 times negative 2x, that's positive 2x all over 2. This gives us x as the answer. Now let's go and solve for the other composition. We have g of f of x. Our g of x, that's given by negative 2x. We have negative 2x. Take note, in this case, f of x will be substituted to the function of g of x. So this means x here will be replaced by negative 1/2 x. We have negative 1/2 x. Now let's distribute negative 2 times negative 1x or negative x. That's simply positive 2x all over 2. So we have here 2 divided by 2, that is 1 times x, we have x. And since the result for both compositions are the same, we have x in here, this means that the two functions are inverses of each other. So that is how you will be showing or you will be verifying if two functions are inverses of each other.